This video is about finding the horizontal and vertical components of vectors. We've talked about vectors as something with a magnitude and a direction. For example, a force is a vector. Here we have a 20 Newton force at a 30-degree angle from the horizontal. What we want to find out is what's the vertical part of this force and the horizontal part of this force. In order to do that, we have to draw it to scale on our paper. Before you can draw anything, you have to choose the scale that you're going to use. Our force is 20 newtons long. So, we're going to have to choose a scale that will allow something of 20 newtons to fit within the size of our grid. For this particular one, we're going to use a scale of 1 centimeter to 4 newtons. So in other words, 1 centimeter on our grid equals or represents 4 newtons. Remember FLM? We're going to use that to figure out how big our force should be drawn. So our force is 20 newtons in length, and we know that 1 centimeter equals 4 newtons. So in order to make newtons cancel out, we put newtons in the bottom, centimeters on top. We calculate that our force needs to be drawn as 5 centimeters. So now we go back to our grid, and we're going to draw the force here on our grid. In order to do this, you're going to need your protractor and a pencil. So the first thing we want to do is find our origin. We'll put it down here near the bottom so we have plenty of room. The next thing we have to do is draw our axes. We need a horizontal axis and a vertical axis. Next we have to notice where the angle is measured from. An angle is always between two lines, so we can see that this 30-degree angle here is between the horizontal line and our force. So we need to draw 30 degrees from our horizontal line to the force. So you take your protractor, and whatever your origin is, where you put that X at the beginning, you line up your protractor, the hole in the very center, with that mark. Then you tilt the protractor back and forth until it lines up perfectly with your horizontal axis. We're looking at this line down here at the bottom and making it line up with our grid marks. Then we look at the markings up here to find the angle that we need. Since we need 30 newtons, we find this spot here, and we make a little dot. Then you take your protractor away. Now you're ready to draw your angle. Since we know that it needs to be 5 centimeters long, I'm going to use the inside part of my protractor here where I can measure in centimeters. I line it up with the origin in one corner and the mark that I just made up here. But I'm not going to extend the line all the way to the mark. I'm just going to make it 5 centimeters long using the measuring tool that's built into the protractor. You can also do it separately with a ruler if you don't have a measuring tool built into your protractor. Okay, now we're almost there. We've drawn our vector. We know that it's 20 newtons long, and we need to find the vertical and horizontal components. I'm going to go ahead and draw those components in blue so I can keep track of where they are. The vertical component is right here, goes from the horizontal axis all the way up to where the vector ends, and the horizontal component goes right along the horizontal axis. Now I want to find out how long these are in newtons. So I start by measuring them in centimeters. I use my measuring tool on the inside of my protractor or ruler, and I can measure that the vertical component is 2.50 centimeters. I do the same thing with the horizontal component, and I can see that it's about 4.35 centimeters. Now I need to convert those over to newtons. So I go back down to my conversions part. So I'll start by converting the height. We said that the height, or the vertical component, was 2.50 centimeters. So using FLM, I have 2.50 centimeters, and remember that 1 centimeter equals 4 newtons. So I'm going to put centimeters on bottom to make it cancel out, and 4 newtons on top. When I do the math, I find that that's 10 newtons. Then I do the same thing with the base, or in other words, the horizontal part. We said that that was 4.35 centimeters. So 4.35 centimeters, where 1 centimeter equals 4 newtons, comes out to 17.4 newtons. Alright, then I go back up to the top, and fill those in as my components. The vertical part was 10 newtons, and the horizontal component was 17.4 newtons. Now we can move on to the next problem. In the next problem, we have a 12 Newton force that's acting at a 65 degrees from the horizontal, but to the left. So again, we want to find the vertical and horizontal components of this force. We're going to start by choosing our scale. In this case, I chose a scale of 1 centimeter equals 5 newtons. So I can calculate how long I need to draw my force. Since my force is 12 newtons, I'm going to convert it over to centimeters using 1 centimeter equals 5 newtons. Again, I'm putting 5 newtons on the bottom so that it cancels out, and I'm left with centimeters. And I find that my force needs to be 2.4 centimeters long. That's not very big, but we'll go ahead and try it. So remember, the first thing I need to do is draw my axes. Since the vector goes up and to the left, I'm going to go ahead and put my origin over here on the right hand side so I have plenty of room to draw the vector. Horizontal axis and the vertical axis. So now I need to draw a vector at a 65 degree angle. So I use my protractor to find 65 degrees. First I line up the X in the middle to the center mark in my protractor. Then I slide the protractor up and down until this black line here is lined up with the grid line. Next I look at the markings of the protractor and I find the 65 mark, which is way up here. The mark is way off my grid, but that's okay because my vector isn't necessarily going to be so long, so I can just make a little mark there and keep track of where it is. Now I know that my vector needs to be 2.4 centimeters long, so I line up the bottom of my marking device here and the top up here where I made the mark for 65 newtons, for 65 degrees. Then I make a vector that's 2.4 centimeters long, and I've drawn my vector. Now I'm ready to find the two components. Again, the vertical component is going to be here, and the horizontal component goes along the horizontal axis. Next I need to measure the two components. First, the vertical component. Measuring from here, I see that the vertical component is 2.15 centimeters. And the horizontal component is 1 centimeter. Next I go back down to the math part where I can convert those centimeter readings into newtons. So remember that the vertical component was 2.15 centimeters. So to convert that, I take 2.15 centimeters, use my conversion factor of 1 centimeters equals 5 newtons, and that comes out to 10.75 newtons. Then for the horizontal, remember that that was 1.00 centimeters. So I can quickly do that conversion, and it's just going to be 5 newtons. Lastly, I go back up to the top and fill those in. Now there's nothing unusual about the vertical component. We converted it and it was 10.75 newtons. Notice that the vertical component here in the diagram is upwards, but we can also see that the vector points to the left. Since it points to the left and the left direction is negative, then the horizontal component is actually going to be negative 5.00. So make sure you pay attention to whether the components are positive or negative. Now for the last problem. Notice the big difference in this problem. Now we have an angle measurement that's not from the horizontal. It's from the vertical. So we have to be very careful about that when we're drawing our vector. So remember, the first thing we want to do is choose our origin. And then draw our axes. Next we choose a scale. In this case I'm going to use a scale of 1 centimeter equals 3 newtons, which means that my 15 Newton force needs to be 5 centimeters long. Now remember, since the 75 degree angle is measured from the vertical, between the vertical axis and the force itself, then when I measure the force, I need to measure it from the vertical using my protractor. So again, I line up the centerpiece there with the origin, and then I slide my protractor until this black line on the protractor aligns with the vertical grid lines on my graph paper. Then I look for 75 degrees, which is way down here. I make a little mark. Now I want to draw my vector, which is going to be 5 centimeters long. Put the 0 down at the origin here, and then slide the protractor up and down until it matches up with the mark that I just made. Again, I'm going to make this one 5 centimeters long. So I draw it like this. Now I need to keep track of the vertical and horizontal components. So the vertical component is here. And in this case, if I measure it, it is about 1.35 centimeters. The horizontal component lines up with the horizontal axis, and it's about 4.8 centimeters. Now I can do my conversions. My vertical component was 1.35 centimeters. So to convert that back to newtons, I use my scale of 1 centimeter equals 3 newtons. Centimeters cancel out, and I get 4.05 newtons. Similarly with the horizontal component, I have 4.8 centimeters. 1 centimeter equals 3 newtons, and I get 14.4 newtons. I can go back up to the top and fill those in. Since I noticed that my arrow points up and to the right, both of the values are going to be positive. Horizontal component was 14.4 newtons, and the vertical component was 4.05 newtons.